day, everyone. It's your favorite math and physics tutor here again. So today we have a topic before us, which is scalars and vectors. So under physics, we're looking at scalars and vectors. So I'll start by explaining what scalars are, and then I'll give some examples, and also go into vectors. Now, scalars in physics, quantities are categorized in two, right? We are classified rather in two. We have the scalar quantity and we have the vector quantity. We have the scalar quantity and the vector quantity. Now, to understand the scalar quantity, this is what a scalar quantity means. A scalar quantity is a quantity that has only magnitude. A scalar quantity is one who has or which have only what? Which have only magnitude. So scalar quantities just have magnitude, they don't have direction. So examples of scalar quantities is we have distance, we have speed, we have temperature. Alright? We have distance, we have speed, we have temperature, we have lots of them like that, right? So all these quantities are scalar quantities. Why? Because each of them has a magnitude, but they do not have what? Direction. So direction is not specified in each of these what? Quantities. So say for instance, for distance now, right? If I say I walk a distance of 20 kilometers, I walk a distance of 20 kilometers from point A to B. Now, 20 kilometers is not a vector quantity, it is a scalar quantity. Why? Because it only has magnitude. It tells us the length or the space at which he or that person has traveled. Alright? So, distance is a scalar quantity. Now, an example of a vector quantity will be displacement. So if you have vector quantity, will be what? Displacement. So a vector quantity doesn't just have magnitude, it also has direction. So a vector quantity is a quantity that has both magnitude and direction. So an example will be something like this. A boy traveled 20 kilometers west. So if you want to represent this on a diagram, this is what you are going to have. So boy starts from, let's say assume the boy starts from A and moves here 20 kilometers west. So let's call this B. So this is displacement. Why? Because direction is specified. And one of the ways we specify direction in physics is by using the cardinal point, right? So direction is specified, therefore this is displacement. So also the same thing goes for speed. Speed is a scalar quantity. So for instance now, I can say a bus or a car, for instance, is moving at a speed of 100 kilometers per hour. This is a scalar quantity. How do we know it is a scalar quantity? Because it only has magnitude. We don't know where the car is going to. We don't know if it's going in the northward direction, in the southward direction, eastward direction. The direction was not what? Specified. So therefore, this is classified as a scalar quantity. Now, an example of a vector quantity will be velocity. So I can as well say that a car moves at a velocity of 100 kilometers per hour eastward, or 100 kilometers per hour east. Now, this is velocity, and why is that? Because direction is what is specified. So please, one thing you need to know is that scalar quantities, they have just magnitude, while vector quantities have both magnitude and direction. So now that we've established that, let's quickly look at some of the things that are important here. Now, we have addition of scalar quantities, we also have addition of vector quantities. Now, when it comes to addition of scalar quantities, it doesn't take much, alright? There is no complexity to it. Just take, if you have, for example, a boy walks with a speed of 20 km per hour and walks another 30 km per hour. What is his total speed? So to simply be 20 km per hour plus 30 km per hour, which will give us what? 50 km per hour. So what I'm trying to point out here is that when it comes to addition of scalar quantities, there is no complexity to it. It is as simple as adding two numbers together, right? Now, but when it comes to addition of vectors, you don't do it like this. Why? Because direction is specified. So there is a certain way and there's a specific method we use in adding two or more vectors, of which we will get into shortly. But just have it in mind and know that scalar quantities can be added and subtracted like normal numbers. But when it comes to vector quantities, we don't do them like that. Why? Because direction is specified. So like we stated earlier, that vector quantities cannot be added with the normal method, right? There's a specific method we use in adding vector quantities. So let's look at that briefly. Addition of vectors. So the reason we are looking at this is because when it comes to scalar quantities, there are no complexity to scalar quantities. You simply take them and add them together. But when it comes to vector quantities, there is a particular method we use in adding vector quantities. Alright, and before I get into those methods, so give an instance of if you apply a force of 6 Newton on a load, and then you have frictional force opposing this motion. So let's say the frictional force is 4 Newton. The frictional force is 4 Newton. So a force of 6 Newton is applied on a load, while a frictional force of 4 Newton opposes the motion. Now, you might be asked, what is the resultant force? What is the resultant force? So to get this, what you just simply do is 6 Newton minus 4 Newton. So resultant force is 2 Newton. So what I'm trying to establish here is that most times vector quantities comes with its own complexities, right? You don't just add and subtract them normally. You have to analyze them and see how to get the resultant vector, of which I'm still going to explain. Now, what is resultant vector? Resultant vector or resultant force, because force is also a vector quantity, resultant vector is the result, as the name implies, you get from adding two or more vectors. In this case, adding also is in the context of subtraction, right? So it's the result you get when you add two or more vectors. That's the basic definition of resultant vector. Alright? Most textbooks or most books will say resultant vector is the single vector that will have the same effect in magnitude and direction as the other vectors acting together. Or simply put, it is the result gotten when two or more vectors are added together. Alright, so now that we've established and we've known what resultant vector is, right? To achieve resultant vector, we must have more than one, right? If you have two vectors, for instance, and you have to find the resultant vector, so it determines, or the question tells us or gives us an idea on how we are going to find the resultant vector. And this is what I mean. Now, let's say for instance, if you have a force of 4 Newton pulling an object or pulling a load, and another force of 5 Newton pulling the same load, you might probably be asked, what is the resultant vector? So the resultant vector simply is the addition of these two. 4 plus 5, which is 9 Newton. Which is 9 Newton. So what I'm trying to establish here is that to get the resultant vector, there is no specific formula. There is no yes, because it depends on the question. In this case now, in the context of this question, the resultant force or the resultant vector was gotten by subtracting these two. But in the context of this, it was gotten by adding them. So that's what I want to establish. Okay, now there are other forms or other ways we use to find resultant vector aside addition and subtraction, just like we did now. We have what we call the parallelogram's law of vector. Parallelograms, or we call it parallelograms method. So one of the ways we add vectors together is by using the parallelograms method. And I'll explain what the parallelograms method is. We also have the triangle method too, but let's quickly touch on the parallelograms method. Now the parallelograms method, it's a law, alright, and the law simply states that if you want to find the resultant of two or more vectors, of two vectors rather, what you do is you represent these two vectors with the adjacent sides of a parallelogram. Represent them with the adjacent sides of a parallelogram. So let's say for instance this is a parallelogram. So let's say probably this is vector P and this is vector Q. So make sure you represent these two forces, alright, by the with the adjacent side of a parallelogram. Now, to get the resultant vector is gotten by constructing or drawing a diagonal. The length of the diagonal gives us the value of the resultant. Now, we have two adjacent sides of a parallelogram. So, parallelograms method simply implies that if you want to find the resultant vector, what you do is that if you are given a question and then you are given two vectors, represent these two vectors by the adjacent sides of a parallelogram. Once you've done that, the diagonal you draw from the parallelogram represents the resultant vector. So this is another way we use in finding resultant vector, aside using this normal method or this principle. We use a parallelograms method. So very quickly, let's go straight down onto a question whereby we'll pick a question and then we'll apply parallelograms method to it. So we have a question here. It says find the resultant of two vectors of 3 units and 4 units acting at a point O at an angle of 45 degrees with each other. So now for this particular question, whenever you have two vectors inclined at an angle to each other, always make sure you use the parallelograms method. Now if it is vectors and they are not inclined at an angle, alright, you can go ahead and use the normal addition and subtraction method, alright. But when it comes to having two vectors inclined at a particular angle, you make use of parallelograms method or you switch to the triangle method, of which we are still going to look at in a further video, right? So let's go straight down into it. Now, find the resultant of two vectors of 3 units and 4 units acting at a point O at an angle of 45 degrees. So let's do this together. Now, solution. So the first thing we have to do is, remember, parallelograms law of vector, we'll say using the parallelograms law, using the parallelograms law. Alright? So let's do that. We're going to represent these two vectors by the adjacent sides of a parallelogram. So let's do that. So we'll call this 3 units. So this has to be shorter than this, while this will be longer. So now this here is our diagonal. Remember we said the resultant vector is the length of the diagonal. Good. So if we can find the length of this diagonal, that gives us the answer to this question. But remember they said they are inclined at an angle to each other at what? 45 degrees. 45 degrees. So let's proceed. Now that we've gotten this, how do we find the length of the diagonal. So this is what we do. Now, looking at this, let's call this, instead of it at point O. So we can call this A, we can call this B, we can call this C, just for identification purposes. Now, since we want to look for the length of this line, we know that we have what looks like the shape of a triangle here. So if I were to bring that out, I would have something like this. So here, I hope you know one of the properties of a parallelogram is that opposite sides are equal. If here is 3 units, obviously here also is 3 units, here also is 4 units. So that means here is 3 units, here is 4 units. Now, the problem now is, or actually it's not a problem, right? Looking at this, we know here is 45 degrees. Another property of a parallelogram, because when you are solving questions involving vectors, or you want to find the resultant of 2 vectors using parallelograms, you must understand the properties of a parallelogram. One I have mentioned is that both sides or opposite sides are equal, and another is that the angles are supplementary. The opposite angles, not opposite angles in this case, right? The angles directly facing each other are supplementary. And what do we mean by supplementary? Supplementary angles are 2 angles that sum up to equal 180. Supplementary angles are 2 angles that sum up to equal, or 3 or more angles, or 2 angles that sum up to equal 180. 2 or more angles rather. Right? So as long as it sums up to give us 180, it is supplementary. So that simply means this plus this must give me 180. This plus this must give me 180. So that means the total angle in a parallelogram is 360. So this simply means if here is 45 degrees, what must be the value of the angle here, such that if I were to add the 2, it will give me what? 180. Remember I told you supplementary simply means 180, right? So that means the angle here must be 135 degrees. How did we get that? 180 minus 45 gives us, so that means here is 135 degrees. If you add it up, it gives you 180. Alright, moving on. So now that we have this, what do we do with this information? Now, to find the length of this line, we simply use the concept of cosine rule. Why do we use cosine rule? Now, we use cosine rule because this is an obtuse angled triangle. It is an obtuse angled triangle. Obtuse in the sense that the angle there is more than 90 degrees. So obtuse angles are angles basically more than 90, right? So this is an obtuse angle triangle. Whenever you have an obtuse angle triangle, you either make use of cosine rule or sine rule, depending on the parameters you'll be given. Alright, let's proceed. So, I'm sure we have been taught cosine rule, and if you've not been taught, I've made a video on cosine rule and sine rule. I've explained it, or I've explained it fully, how it was derived, how we can apply it. So please make sure to do well to check that video. Alright, coming back, we'll say using cosine rule. So let's call this is O, this is B, and this is C in triangle OBC. So obviously our main goal here is to find the length of this diagonal, which is R. So let's do that together. If here is O, yeah, this is length O. If here is C, this is length C. If here is B, this is actually length B, right? But we can also call it R. This is resultant vector. So since I'm looking for length B, which is still the same as R, I can say B squared using cosine rule is equal to what? O squared plus C squared minus 2OC cos B. So this is cosine rule. Oh yeah, let's go. Now, I'm going to say B squared, O, which is the length, is what? 3 squared, that's 3. And then c, which is the length of this, is what? 4 squared minus 2 times, we have o, which is 3, we have c, which is 4, and then we have cos what? B, which is what? 135 degrees. So now we have b squared is equal to, this is 9, this is 16, this is 12 times minus 2, that's minus 24, and then cos 45, let's punch that on our calculator. That will be giving us a negative value. Why? Because cosine is negative in the second quadrant. So when you multiply this together, we have 25 plus 16.9704. And when you add this, we have, let's add it together, plus 25. That gives us 41.9704. So we have to find the square root of this. So let's do that quickly. The square root of that gives us b is 6.47. 6.784. So to make our answer, alright, in short form, let's just leave it in 2 decimal place. So therefore b is 6, or 1 decimal place rather, 6.5 units. So therefore the resultant vector, or the resultant force, resultant vector rather, is 6.5 units. So this is how to find the resultant vector using parallelograms method. So, and I said that you use parallelograms method when these two vectors are inclined at a certain angle. Alright, so thank you so much for watching. We also have lots more to look at. We have a lot actually. We still have more components of a vector, resolution of vectors, and more and more and more. So today, right now we're going to be wrapping it up. So thank you so much for staying to the end, and see you in the next class.